But we know that sometimes just knowing the mean or the median might not be all that helpful. So in the case of wages, knowing that it's $35 an hour is the average or the mean wage doesn't say much about where that's spread out in the population. Is it a lot of people having really high salaries and a lot of people having really low salaries, but then they average out to 35, or are most people making a $35 an hour, which is quite a good wage. So, we'd be pretty confident that our society was doing quite well at, providing for everyone. So that's why we want to know not just measures of central tendency, but we also want to know measures of variation. Okay, so the first measure of variation is range. So pretty simple, just like what you would expect it to be. So let's just, let's just copy this just so that you can have another sheet with that on it. So if we wanted to find out what the range was, what we do is we just let's just make sure we're on filter. Make sure we're from smallest to largest. All right, so what we would do is we would take the largest number minus the smallest number, so 56 minus 10, so that is 46 plus 1, which is 47. So that means between 10 and 56, there are 47 values. Let's go back here. So the highest number, so in this case, let me just write this down, 56 minus 10, which is plus 1, which equals 46 plus 1, which equals 47. All right. So again, this might be really useful because then we would know, are there people making $100 an hour and then people making, $2 an hour? Like, what's the amount of spread that we have between the highest and the lowest in the range? The other thing we might want to know is the standard deviation. So it's even like a more sophisticated version. Essentially, standard deviation is essentially the average of the distance to the average. Okay, so let's go back to our little graph here. Where was it? Right here. Okay, so we have our mean right here. We want to know what is the average distance of any one of these points. So like imagine we had each of them as its own point. What is that observation's distance to the average, and what's the average of that? Okay, so let me explain that in terms for hourly wage. So in our case, of wages, there would be some societal implication. If there is a low standard deviation, that tends to mean that the values are very close to the mean. And so that would mean that, let's just draw it here, the shape of our normal distribution would probably look something like this. So most people tend to be close to the $35 an hour. Now, what does that mean for society? It means, well, like most, a lot of people tend to be making close to $35 an hour, a little more, a little less, but the bulk of the people are close there. So that low standard deviation says something about, most people are doing pretty well for themselves. Now, if we had a high standard deviation, that means that there's a higher average distance to the average, or higher average distance to this mean. So that would look a little bit more like, how do I do that drawing tool again? So that would look a little bit more like this. So it would mean that we have a lot of people actually, on these ends. And that would mean that, okay, so, it's larger, which means that it doesn't necessarily mean that everybody's making the same amount of money, that there's quite a bit of spread in terms of what different people are making. And you could even find, like, it would probably even more so look like, let's see if I can just edit this. Yeah, it would probably more so look like that because there'd be like less people. Yeah, it'd be like, remember we talked about flattening the curve or cattening the curve? It's kind of more what we're talking about right there. That was a very large dome. Okay, so anyway, so point being, the thing to remember about standard deviation, the way I always remember it, is the average distance to the average. So for every observation, we find out what the distance is to the average, and we take the average of that. All right, so let's actually do that now. Whew. Let's move over here. Let's get back to our data set. This video is just going to be like me moving windows around. Maybe I should get multiple windows. Not that one. This one. Okie dokie. All right, so here's in our new sheet. So we want to do the following to find out what the standard deviation is. All right, so first what we're going to do is we're going to calculate the mean, which we earlier said was about $35, minus the hourly wage of each person. So that means we're going to do 35 minus whatever that person's hourly wage is. So that is each person's distance to the mean. So you could be, you know, you could have to go forward 25 steps, or you could have to go back, you know, 15 steps to get over to the mean. So now what we're going to do is we're going to square it, because we don't necessarily care if they have to, if they're bigger than the mean or smaller than the mean. We just want to know what's the average distance to the mean. So second step is to square it. So, wow, that is totally not how you spell square. Square it. There we go. So here we're going to do, essentially squaring just means you're multiplying it by itself. So, and what I'm doing is I'm just dragging down to get each of these. Boop, there we go. So that it'll just fill it in for each of the values. All right, so next step now is to add all of those numbers together. So let's auto sum, or we could, you know, use paper and pencil, but I don't think anybody wants to do that. So our auto sum, 3,400. Okay, and now what we're going to do is our next step is to divide by the number of respondents. So essentially we're taking the mean. So we're going to do 3,400 divided by 30 respondents. So it's about 113-ish. And now we're going to take the square root, because remember we took the square root over here to get rid of all these little negative signs. So we're going to have to take the square root again. I'm not even sure if I can take the square root on here. Let's see if we can do. I'm sure there must be a function for square root. Formulas. More functions. Let's see square root. Square root. Oh, 113. Oh, cool. So it's about 10.6, so roughly about 11. You'll notice when we do stats, or at least the examples that we're doing, we're going to be rounding quite frequently. All right, so it's about 11. So let's go back to drawing one standard deviation from the mean in each direction. So let's go back to this guy. So I want to draw a line that's one standard deviation, so about 11. So it would be about over here somewhere. And then one standard deviation below. So that says that, you know, the average distance to the average is about $11. So, you know, we got some spread, but not like there's no kind of clear set. It really depends on what your data set is about to say, like, this is a high standard deviation versus a low standard deviation, because it depends on so many things. But at least now we know here's the distance, the average distance from the middle. So now let's take, and I think it's something like 68% of data is, I'm going to have to fact check that one, is within one standard deviation of the mean. I'm going to fact check that though. I don't have it in front of me. I will let you know in the description to this video. Okay, so the last thing we want to do is kind of think, okay, substantively, what does that mean to be one standard deviation from the mean? So let's think about your hourly wage as an officer cadet. Let's see if I can find that out. YouTube. Hourly wage as an officer cadet. CAF. How much do you guys make an hour? Oh, $14 an hour. All right, so let's pretend you make $14 an hour, which is, I think, minimum wage. So you are more than one standard deviation from the mean. So you would be more like hanging out over here. So you guys are definitely not within the bulk of the observations. You are much lower. And so in that way you can tell if somebody says like, oh, I make $70, and you'd be like, oh, like that's quite a few standard deviations from the mean. Like that would be if the mean is $35 and you're making $70 an hour, then your distance from the mean is 35. So that's like 35 divided by 11 is about like 3 standard deviations from the mean. So you're way up in the high part of the data. So it kind of gives you a sense of where you are or where each observation is relative to the other observations and relative to the mean. And again, that's interesting and useful because unlike mean, where it just gives you one number and you don't really know much about the spread of the data, knowing the standard deviation can help you know more about the spread. Fun fact, this is called the Z-score. When you take essentially your wage. So like, let me just write this down so you can see, because I was doing this on a piece of paper and you obviously can't see that. So if you have your $14 an hour minus $35, it should be wage, $35. So that is, I'm just going to do 35 minus 14. So you're like 21. And so 21 divided by 11 is almost 2-ish. So you're about 2.